This is section 3.4 practice A. We're going to do some problems from this bottom section on this sheet. They ask you to tell whether the lines that go through the given points are parallel, perpendicular, or neither. It's just like this previous section, parallel, perpendicular, or neither. Only difference is we counted to find the slopes here. On these ones, we're not going to count. We're going to use our formula for slope. So notice how they basically give you no room to do any work at all. So it's totally acceptable if you get a separate piece of paper so you can find your slopes. So this is going to be the slope for line 1 for number 10. What I need to do is I need to subtract my y values, put them on the top, subtract my x values, put them on the bottom. My y values are 5 and 3, so I'm going to put 5 minus 3 on the top. Now since I chose 5 first, I'm going to choose this x first. -1 minus -1. Now hopefully you should notice that these x's are the same. When your x values are the same, that should tell you something about the line. If you don't know, you're going to realize it real quick here. -1 plus, that's when you subtract a negative, -1 plus 1 gives you 0. What kind of a line has a 0 in the denominator? This is a vertical line. 5 minus 3 is 2, but that doesn't really matter. Whatever number is up here, you can't divide by 0. So the slope is undefined. This is a vertical line. So you can write undefined slope Now, that's just one slope. You need to find the slope of line 2. And then we're going to compare it with the slope of line 1. So we're going to subtract again, difference in y's, difference in x's. Our y's are 6 and 0, and then our y's are 0 and 0. And again, that's going to give you a 0 in the denominator. So this is a vertical line, and it's an undefined slope. Two vertical lines, are they parallel? Are they parallel, perpendicular, or neither? They're parallel, and this is how you're going to write it. Line 1, line 2, parallel mark in between. If you want to just write the word parallel, that's fine too, as long as you have your work. But this is the mathematical way to write it. So the more you write this, the better off you're going to be, because you're going to start understanding it because you're writing it. Let's jump over to number 11, and we're going to do the same thing. We're going to find our slopes. So this is the slope for line 1. We're going to do 3 minus 1 and 3 minus 1. 3 minus 1, 3 minus 1. That gives you 2 over 2, which is totally off the page, which is 1 over 1. That's your slope of line 1, 1 over 1. Now you need to find the slope of line 2. So we're going to do that as well. We're going to subtract our y values and put them up top, 4 minus 2. Then subtract our x values, 0 minus 2. 4 minus 2 is 2, and 0 minus 2 is negative 2. Again, that's going to reduce, but notice how the sign's different. Okay, so this is a good example to look at because this is positive, this is negative. What's the reciprocal of 1 over 1? When you flip it, it's still 1 over 1. So these are opposites and they are reciprocals. So line 1 and line 2 are perpendicular, opposite reciprocals. If your slopes are the same, they're parallel. If your slopes are opposite reciprocals, they're perpendicular. Let's do one more. This is number 13. Ooh. Yeah, let me fold this back. Let's find the slope of line 1 in number 13. So we're going to take 2 minus 3, and we're going to take negative 5 minus negative 2. 2 minus 3 is negative 1. Negative 5 minus a negative 2, that's like negative 5 plus 2. That gives you negative 3. Negative divided by negative is a positive, so you could just write your slope as 1/3 there. Let's find the slope of line 2. We're going to do 3 minus 1 for the y values, and we're going to do 5 minus 4 for the x values. You get 2 over 1. That doesn't simplify. Does it match 1 over 3? It doesn't. Are these opposites? No. Are they reciprocals? No. What's the relationship that these lines have? Well, they're not parallel and they're not perpendicular, so we're going to write neither. Now, what does that really mean? Well, if I could do my best to kind of graph this for you, if you have a slope of 1 over 3, the y-intercept could be anything. Maybe it's a line that looks like that. If you have a line that has a slope of 2 over 1, it's going to look a little like this. It's a little bit steeper. Notice what happens. They're crossing, but they're not crossing at a right angle. So when we write neither, that just means they are touching each other, just not at a right angle.